Okay, for this diagram, it shows the different kind of deployment. The traditional deployment style is that we have the hardware and operating system. We need to install the applications in the same operating system. Then we have the virtualized deployment. That means above the operating system, right? We have the hypervisors, right? Or simply consider the hypervisor and several virtual machines. So in each virtual machine, we have isolated operating systems, libraries, and applications. As we mentioned before, with this virtual machine-based solution, it's heavyweight. For container, we find a way to provide a lightweight, isolated environment. The constraint is that we share the same operating system kernel. Okay? For example, if it's Linux kernel, then all the applications inside should be Linux based. Okay, so this is the history. Then let's consider the Kubernetes components. Okay, I think let's quickly go through the components because we are not focused on the exact implementation of the components. So here are the core components, like the kube API server. For API server, this is the core component server that exposes the Kubernetes HTTP API. It is used for controlling. Just consider we use the API server as the gateway, and we can issue the command to the API server. Then the API server dispatch the requests to the nodes for managing something. etcd consistent, highly available key value store for all API server data. etcd is a critical component in Kubernetes. It uses the key value store for storing various kind of information, and part of them is the current status of your cluster, the nodes, the pods, the services, the containers. So it is updated frequently, and etcd is it's a bottleneck of the performance. If you would like to have a smooth and high performance cluster, it's better to configure the etcd to run at high speed, very high speed storage. Then kube scheduler looks for pods that not yet bound to a node and assign each pod to a suitable node. It schedules. The schedule is not about time. It schedules the resource to some other containing resources. Here is a pod and node. So when we would like to start a pod, it schedules the pod to a specific node. Maybe the node has lower system load, so we schedule the pod over there. Then kube control manager, it's the controllers. In Kubernetes, there is a control plane for controlling the cluster. Okay, then for each node, we have the kubelet. Kubelet ensures that pods are running, including their containers. So the kubelet is kind of the local manager, right, for controlling the life cycle, right, of a pod. And kube proxy is used for dispatching the requests among the nodes, pods, and containers, okay, especially for the cluster and cluster level and node level and pod level. Container runtime, of course, is container-based solution, so we need a container runtime at each node. There are some add-ons like the DNS. Right? We have an internal DNS enabled for resolving the services inside the cluster. Then objects in Kubernetes, I think this section is a little bit complicated. Just consider in Kubernetes, each resource, right? The resource may be a different level, like a node resource, a pod resource, even a deployment specification. Deployment is also a kind of resource. So we just consider the resource, okay? We describe, okay, a resource as a kind of object. And for each object, it is memorized, or it is saved in the system, and the Kubernetes system ensures that the object properties is up to date. And sometimes based on the object policy, according to the policy specified in the object, it may do the necessary management actions to the target resource. I think for this part, it's not only abstract but also complicated. Maybe it's better to come back once you get familiar with the fundamental Kubernetes operations. Okay, then let's go to the I think Kubernetes API is not the okay, I think we can skip this part. Then the kube, right? kubectl. This is a command line tool, and basically we can do almost everything via the kubectl. So for this program, we can specify the commands, right? And the command will be sent to the Kubernetes API server for controlling or revising the properties of the cluster. So the kubectl tool connects to the API server and authenticates using the cluster user context defined in the kubeconfig file. Okay. So later you will see that we will write some specification files and then use the kubectl to issue the request to the Kubernetes. Okay, then here is a cluster architecture, slightly different from the diagram I provide you. This is the official one, that in the cluster there are nodes, and some of the nodes enables the control plane functionality. So in the control plane, basically we have the kube API, etcd, scheduler, control manager, and so forth, right? And there could be multiple nodes supporting the control plane. This is a high availability configuration. So suppose currently one node is responsible for the control plane, and the others are just the backup. Okay? So once, suppose the current controller crashes, then the backup controllers or backup nodes would quickly vote for a new controller node, and it takes over the control sequence and control tasks. Right? So this is the structure for the cluster. And in our learning environment, the practice environment, since we have only one node, so the only one node should enable the control plane, and it also works as a worker node. Okay. So control plane components, the API server, etcd, scheduler, control manager. Okay, so basically the duplication of the previous. Right? Okay. If you are interested, you may go through the specific introductions like nodes, the communication between nodes and control plane, controllers, and so forth. Okay. Here we will just skip this part, right, because it's the low-level design or the detailed design of the Kubernetes. Right. And containers. Right, these are for containers, of course, we need a container image. We need a container runtime. Okay, it's just like the Podman or Docker. Right. Then workloads. Right. In the workloads section, we introduced the pods, workload API, workload management, and so forth. I think we may learn the pods concept. Given the pod, okay, we know that it's kind of network computer, virtual network computer. So when we need to specify a pod, right, this is the pod object. So you could see that it's a YAML file. When we provide a YAML file specifying the API version, right, that's the Kubernetes API server. So the API version, okay, is the kind is pod. So we would like to specify a pod. The metadata, okay, the pod is called Nginx, okay, and the spec section is the key point. For the spec section, we specify that in the pod there could be multiple containers. Typically, we would like to just run one container, one container per pod. In some specific cases, like two containers should share like a volume, then we may design a multi-container pod. Otherwise, in many cases, we just use a single container pod. So here, the container name is Nginx, its image, and its port. The container port is 80. We do not specify the target port. Target port is the port at the pod level. By default, okay, it is the same as the container port. Okay, then once we prepare the YAML file, later we use kubectl apply -f and then supply the YAML file. It could be URL, could be a local file, and the object will be created in the system. And if the object also represent a kind of runtime resource, then this will also be created. Okay. So working with pods, I think these are just the okay, and this is another example here in the this is a job object. Okay? I think in our introduction we will not talk about the job, but later you will see that in the deployment we will frequently use the template. The template that means under this kind of object we refer to the pod specification. So the template is actually the pod template. Okay, then I think we can just skip the other part, and in the next talk, I will talk about the important one called deployments. For beginners, I think we start from the deployment, and within the deployment, we also define the pod and define some other resources. So usually we can just use a single deployment file to deploy our application, including the pod structure, the container definition, and so forth. So in the next video, we will talk about this.